Welcome to our last video in the Law of Exponents series. This is video number 6. We're going to talk about negative exponents and the negative exponent rule. I kind of think this one's a little difficult to understand, but nonetheless it works. And we're going to talk about this today, okay? So our formula, for those of you keeping track, when we have a number, okay, x to the negative n power, so this might be 4 to the negative 2 or 17 to the negative 6, okay, we have x to the negative n power. What we're going to do is we're going to flip it. We're going to put it in fraction form. This becomes 1 over x to the n power. Okay, and x cannot equal 0 here. You can't divide by 0, so x cannot be 0. Basically what this means is that the negative sign on this exponent right here means that we're actually going to take the reciprocal. If you remember reciprocals from the past, we had 4/3. The reciprocal of 4/3 was 3/4. Okay, some of you called it the flip-flop. Some of you called it flip reciprocal, okay? Where our numerator becomes the new denominator and our old denominator becomes the new numerator. So we're going to flip these. So that's what we're doing here. X to the n, negative n, is equal to 1 over x to the positive n. Because we're doing that flip, we're going to also change the signs, okay? So a positive exponent, when you had something like 4 to the 3rd power, that positive exponent means that we're having repeated multiplication. Remember, the exponent tells you how many times your base repeats. So that's where we have the repeated multiplication. A negative exponent is going to mean repeated division. So what does that look like? Here's an example. We have 2 to the negative 4. That is going to equal to, I'm going to put my 1 here. You can think about this like this, negative 2 to the negative 4 power over 1. We're taking the reciprocal. Old denominator becomes new numerator, okay? So this becomes 1 over 2 to the positive 4 this time, okay? What does 2 to the 4th power look like? 2 times 2 times 2 times 2, which is equal to 16. So what we're showing here is that 2 to the negative 4 power is really equal to 1 over 16. So why? Why does this work? You know, we're always talking about the why. Why does this work? Let's think about powers of 10, okay? If you have 10 to the 3rd power, that means 10 times 10 times 10, which is 1,000. 10 squared is equal to 10 times 10, which is 100. But look what I've done here. I've taken 1,000 divided by 10. I get 100. 10 to the 1st power is 10. It equals 10. Again, dividing 100 by 10, I get 10. If I continue this pattern, here's 10 to the 0 power. Remember video number 5, we talked about 0 exponents and how any number to the 0 power is equal to 1. I'm just dividing by 10 again. If I'm looking at my exponents here, I'm just subtracting 1 each time. So 0 minus 1 is negative 1. 10 to the negative 1 power is equal to 1/10. How do I know that? Because 1 divided by 10 gives me 1/10. 1/10 divided by 10 gives me 1/100th. Looking at my exponents, if I subtract 1, negative 1 minus 1 is negative 2. 10 to the negative 2 power is equal to 1 over 10 squared, which means 1 over 10 times 10, that's 100, okay? So why does this work? Well, we're just basically dividing by 10 each time on our powers of 10, okay? That shows you why we can just take this negative exponent here, drop it to the denominator, and make it positive. So let's look at some examples. We're just going to change this into a positive exponent. Okay, we don't really have to solve it right now, but we're just changing it. So 4 to the negative 3 power means I'm going to take my 1, that's automatically the numerator, automatic, okay? And I'm going to bring my 4 and my exponent down, but I'm going to make it positive. So 4 to the negative 3, I'm flipping it to the denominator, so it becomes a positive 3. Now, if we did want to solve this, we would take 4 times 4 times 4. 4 times 4 is 16. 16 times 4, 64. So this is 1 over 64. Okay. If I look at 7 to the negative 2, I'm going to rewrite it first as a positive exponent. 1 over 7 squared. To evaluate this, this is 1 over 7 times 7. 7 times 7 is 49. Okay. So 7 to the negative 2 power is equal to 1 over 49. Now, how does this look on your calculator there? Well, if we clear this out, I can enter, there's my 7. I'm going to hit my caret, and I'm going to do to the negative 2. I'm going to type it in just like I want it. It's going to give me a decimal equivalent, but that's how you would enter it here. 7 to the negative 2 power. So what is that, 0.020408? What do we get here if we take 1 divided by 49? Whoops, clear that out a second. 1 divided by 49. I get the same answer, okay? Just my calculator is going to give me a decimal answer instead of fraction form, okay? All right, so let's look at some more examples. I have 3 to the negative 4 power. I'm going to rewrite that 1 over, that 1 is always going to be in my numerator, okay? And then this becomes 3 to the 4th. If I rewrite this, that's 1 over 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 gives us 81. Double checking that on my calculator too, just to make sure, okay? And then here we have 8 to the negative 2. We're going to rewrite that as 1 over 8 to the positive 2. This is equal to 1 over 8 times 8. And that gives me 1 over 64. Okay. Now we can reverse it too. We can go backwards. We can start with positive exponents in the denominator and reverse them to negative exponents. So what happens is, if I see something like this, 1 over x squared, all I'm going to do is I'm going to take whatever is in the denominator and I'm going to change the sign on the exponent. Okay, so 1 over x squared is equal to x to the negative 2 power. With this example here, 1 over 4 cubed, that becomes 4 to the negative 3 power. If I'm moving from denominator to numerator or numerator to denominator, I have to remember to switch the signs. Okay, I have to remember to switch the signs. With this problem here, even though we have 2 variables and 2 exponents, it works the same way. Start with the w squared. You know, we break things into parts all the time. Start with this. This becomes w to the negative 2 power, y to the negative 3 power. And we're done. Okay, we're done with that. So using previous exponent laws, for example, this one right here, our product of powers property, we learned a while back that if the bases are the same, here I have bases of 4, if they're the same, we're going to end up adding the exponents together. So in this case, I have 5 plus negative 8. Well, a 5 plus negative 8 is equal to 4 to the negative 3. 5 plus negative 8 is negative 3. And I'm going to rewrite it using a positive exponent, 1 over 4 cubed. When we were using the quotient of powers property, that rule, remember, said you subtract the exponents if your bases are the same, which in this case they are. So we're going to subtract the exponents. We have negative 1 minus negative 3. Be really, really careful when you are doing this. Okay, there are a lot of negative signs in here, lots of subtraction signs. Remember, we can add the opposite. That rule came into play a while back, so I end up with negative 1 plus 3. This turns out to be x squared. It's a positive exponent. I do not have to change it to fraction form. Typically, you're going to leave your exponents in a positive with a positive number. You don't want to typically leave them as a negative exponent unless the directions say specifically to do so. Okay, so with that being said, this is a very abbreviated lesson here on negative exponents. What you need to remember is that we're dealing with reciprocals here, okay? So whatever you have to a negative exponent, that is going to become 1 over x to that positive exponent. All right? That concludes our series on the laws of exponents. Check out the other videos if you need some more help, and we'll see you next time. Bye.